All right, in this video, we're going to talk about arrays and kind of hit on a lot of the same things that we talked about in class. So what I've done here, and I think this is just the easiest way to show it again, is just to kind of trace a program that I've already written. So I'm not going to write something as we go. This is already written. And what we're going to do is we're going to trace it and give you guys an idea of exactly what's going on, particularly as it matters or pertains to arrays. So what we have here is my project in NetBeans. What we have over here is just an Excel spreadsheet I have open so we can track variables and talk about the values and what's stored where and how they conceptually look in memory and that sort of thing. Okay, so let's start right here at the top, right? So we come into our main method. We see the first thing that happens is we create a string array. Now we can tell it's an array because it's got a data type and then these single brackets, the square brackets. And it's called days of the week. So we're going to have a variable created called days of week. It's a string array. Its scope, because it's declared inside the main method, is the main method. And its value, if you look at what's on the right-hand side of the equal sign, the value is actually inside of curly braces. It's got curly braces, and then it has 7 items. These are all strings that are comma separated with a semicolon there at the end. Now this is one way that you can declare an array, and this is basically a way to hard code the values of an array or declare them up front. You'll notice that whatever is going on here in terms of the data types inside of these curly braces must match the data type of the array that you declared. So if you said this is a string array, then inside these curly braces you must have a string. If you said this was an integer array, you would have a comma separated list of integers. If you said it was a double array, you could have a list of decimal point values inside here. If you had a Boolean array, you'd have true false comma separated inside of here. Doing or declaring arrays this way, there's no sort of hard specification of the length of the array. The length of the array is actually derived from the number of values that you include inside of these curly braces. So in this case, we would create an array called days of the week that would get stored in memory, and the array would look something like this, right? We would have an array that has Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And this is basically our days week array, right? So conceptually, in memory, we have something that looks like this, right? It's got an index, right? So this would be 0, 1, 2, 3, 4, 5, 6, right? So if we wanted to talk about days of the week at index 1, well, we would be talking about the value Tuesday. If we talked about days of the week at index 5, we'd be talking about the value Saturday. What's interesting to note, and we'll see this later on in this video, is that what actually gets stored in memory in terms of the value of the array is actually a bunch of garbage. It's actually a memory location that actually points to where the array is sort of conceptually held inside of memory. This becomes important later on, and we'll talk about it a little bit later, but just want to be cognizant of that right now. So if you talk about days of the week, you're basically talking about a pointer reference to an area of memory that's pointing to something that conceptually looks like this, right? The length of this array is 7, right? 1, 2, 3, 4, 5, 6, 7. But because Java indexes everything starting with 0, the very first entry is 0, the last entry is 6, but we still have a length of 7. So that's the first line of code. So all of that just took place in the first line of code. We have something called days of the week. It's the days of the week, Monday through Sunday. It's the length of 7. It's got an index from 0 to 6. And what we can do now is we can do things with our array, right? In this example, we're doing something very simple, which is just going to print the array. And if I run this right now, you'll see that all it does is print days of the week, and then it prints whatever is inside of our array, right? Now let's go look at what that actually looks like. So if we go to print array, you'll notice that I have 3 versions of the print array method. One version accepts a multidimensional array, which we'll talk about in just a little bit, so that's not the one we're looking for. And then we have another print array that takes an integer array and we have another print array method that takes a string array. Now, since we know that this is a string array, when we call print array up here in our main method, right here at line 11, Java figures out, the compiler figures out that this is the method we're talking about because we are giving it a string array. So we'll ignore this one and we'll begin right here. So the first thing it's going to do is print out the label. So if we go back and look up here, the label is the second argument, and it just says days of the week. The first argument that we pass the method is the actual array that we want to print, right? So the first argument that gets created, or the first variable that gets created is called A. It's a string array. The scope of this array is the method print array, right? That takes a string array. We'll make that clear since we have multiple print arrays. The value of A is actually going to create a new array. So if we look at this, again, there's going to be junk in here, and essentially what's going to happen is this array is going to get copied over, all right? So now this is basically A, and that's because we're passing it this array, right? So it's creating a new instance of array A. Now what we want to do is we want to print the label. So you see that we do that here, which was days of the week. The next thing we do is we create we hit a for loop. And inside, actually I skipped that. Let me go ahead and just to be sure that we're covering everything exactly, right? This is going to be days of the week, right? Okay, don't want to miss that. All right, now so we're going into our for loop. We printed whatever was in label, right? We have this thing called label, it had days of the week value in it. That's the first thing we do is we print days of the week. The next thing we do is we hit our for loop, and when we hit our for loop, the first thing we're going to do is declare our new variable. It's called I. It's an integer. Its scope is the for loop, right, inside print array. And its value gets initialized to 0. All right, so the first thing we do after we declare the integer variable for our for loop is we check to see if this condition is true. Now, a.length is the length of the array, right? And the length of this array is 7, right? 1, 2, 3, 4, 5, 6, 7, right? So we're saying is I less than a.length, which equals 7? Well, I is 0, so 0 is less than 7. That's true. So we'll come into the body of our for loop, which just says system.out.println a at index I. Well, a at index I is 0, is going to be the value of Monday. So we're going to print Monday, and then we're going to print a space. We're going to come back up. We're going to increment I. I is going to become 1. We're going to check to see if 1 is less than 7, which it is. So because 1 is less than 7, this is true. So we're going to do the bottom body of our loop again, which is going to print a at index I. Well, I is now 1. Index 1 of array A is going to be Tuesday. So now we're going to print Tuesday. We'll come back up. We'll increment I again. I will become 2. We'll check to see if 2 is less than 7. 2 is less than 7. That's true. So we're going to come in here. We're going to print A at index 2, which is Wednesday. So you can see what's going on here. You can see that this is going to iterate through the entire array. Once we get to index 6, we'll say 6 is less than 7. So we'll print A at index 6, which would be Sunday. So we would be down here printing Sunday. We would increment I again. I would become 7, and 7 is not less than 7. So we would drop out of our for loop, and then we would simply print a carriage return at the end of the line. So our cursor would now, if we elected to print something else, would be right here. Once we hit this line, we also hit the end of our method, which means that all these variables we created temporarily for use by our method go away. All of this goes away. Oops. And essentially we return back up here to where we left off, right? Days of the week is still out there. Its scope is still main. It still exists. And all we basically have done so far is we declared an array Monday, Tuesday through Friday, Saturday, Sunday, and then we printed that array. All right, so that's why our output looks something like this. Now I'm going to comment this out, and we'll go on to our next way to create an array. Mind you that because we haven't done anything to get rid of or destroy or dispose of the variables and stuff that we've already created, those will just persist. But I'm just commenting out the print statements so that we don't have to see them and we can kind of focus on what we're looking at. All right, so the next thing we do is we declare a string called s. Its scope is main, and if you look at its value, it's something like this, right? It's a list of numbers of integers specifically, not in any particular order. Looks like they're all prime numbers. And so then the next thing we do is we create a new array called prime string. Oops, this is not a string array, this is just a string. This is a string array. The scope is main, right? And we look at what's going on in this line. So we declare a string array. We know it's an array because it has the brackets. It's called prime string. And we're assigning it the value of s.split. Now, split is a string function. It's a string operator that you can perform on, it's an operator you can perform on strings. In this case, we're going to perform it on the string s, which we just declared, which has this value in it, right? Now, what we pass this method called split is a delimiter. So basically what we're saying is we want to delimit this string by whatever is inside these quotes. In this case, it's just a space. Could be a comma, could be a semicolon, could be another word, could be a lot of different things. But basically what you're telling the Java is that you want to take this string that you have and you want to split it and create an array based on delimitation of whatever you specify. So in this case, a space. So what this is going to do is this is going to create a new array called prime string. And inside this array, we're going to split on spaces, which means that every time we see a space, it's going to split the string. So we're going to get an array that looks like this: 17, 7, 11, 13, 23, 2, 3, 5, 5, 19. And again, this is going to be indexed 1, 2, 3, 4, 5. All right, so we have a length of 9, right? But we have an index going from 0 to 8. Again, in memory, this looks like whatever. Doesn't matter. It looks like garbage. But really, this garbage is pointing to this array down here, okay? All right, so the next thing let's do is let's uncomment this and, well, oops, we don't want to comment that. We want to comment this. Let's go ahead and print this array. Now this time when we call our print method, we're still calling, or we're still sending it a string array, right? We're saying I want to print the array called prime string, and I'm going to pass it the label of original prime array. Now I'm not going to trace that method again. I'm not going to trace this process again, but we saw earlier that this method basically loops through each index of the array and prints out whatever value is stored in that index. Notice that we didn't hard code a value here, right? Because here we were dealing with a length of 7. Now we're dealing with a length of 9. If we had put 7 here while I is less than 7, that would have worked very well for this array. However, if we tried to reuse it for this array, it wouldn't work for us, right? We would stop right here and we wouldn't print the 5 or the 19. So that's why it's really important that when you build arrays that you abstract them, you try to extract them to the highest level you can, and try to avoid hard coding values that make your array's utility very specific to a purpose. So if we run this now, right, we've created our string that looks like this. It's a string of prime numbers separated by spaces. We then use the split function to create a string array of those same values. And now what we're going to do is we're going to print the array. So if we print this array, you'll see, no surprise, it's going to print 17, 7, 11 right on down, right? Because it works just like we just saw with the other example. Now suppose we wanted to sort this array, right? Right now we want to sort this array. If we try to sort this array, there's a really nice function or class called arrays that has a method called sort, and you can give it an array, and whatever array you give it, it will sort that array. Now arrays is actually, it's part of another library. So in NetBeans, if you're using NetBeans, if you type arrays, it knows that you need to import this library. But if you're doing it, in some other less intelligent IDE, you might have to declare this up here at the top yourself. So just remember that if you're going to use a sort arrays.sort, you need to make sure you pull in this java.util library, and that will work for you. So we're going to print the array, which is the original array. We're going to sort the array, and then we're going to print the array again. This time we're going to say we're sorting. It's the sorted prime string array. Now, if we sort this and we print it again, we're looping through the array. It's sorting the array for us, right? So in fact, if we go back and look at this thing now, it will actually be in a sorted order, which would be 11, 13, 17, 19, 2, 23, 3, 5, 7, right? When we call this method arrays.sort, it actually touches our array and it changes it, right? So we have reordered our array. The indexing stays the same, right? The first cell is still 0. The last cell of the array is still index 8. Our length is still 9. However, when we print our array now, you'll see that it is sorted in order. Now, it's not sorted in numerical order. It's sorted in alphabetical order, right? Which is why we get sort of the weird sorting order. Now, the reason it's sorting in that order is because our array is a string array. If we wanted to sort in numerical order, we would have to do something to create an array that's an array of numbers. And then when we use the sort method, it will sort numerically instead of as strings. So let's try to do that. Now, there are ways to do that that are a lot more maybe easier than what I'm going to show you here, and that's fine. But really, what I want you guys to get used to with this particular example right now is really kind of the idea of working with arrays rather than using something that's that does it for you. So the next thing that we're going to do is we're going to create a new array. Now, if you're just declaring a new array, but you're not actually putting anything in it, or you're not using some other hard-coded list or static string of values, or if you're not using the split function that's built on something else, declaring the array and not putting anything in it is a little bit different. So the first thing you're going to do is you're going to have the type, right? We've already kind of seen that. You're going to have the type of the array that you want to create. You're going to have the single brackets. You're going to have the name of the array. You're going to use the keyword new. Then you're going to specify the data type again. And then you're going to have an open bracket and a closed bracket. And inside that open and closed bracket, you're going to put a number, an integer, that specifies the length of the array. Now, if we want to get this prime string array into another array that maybe we could sort numerically, it makes sense that we want this new array that we create, so let's just say we create it right here, to be the same length as our prime string array, right? So we're going to call this array prime int, and we're actually declaring it, right? So prime int, it's an integer array. It's in our main method. Again, it's garbage for what's actually stored in the value of that variable. It's actually a pointer to a memory location. In this case, it's going to be down here. When you declare a new integer array, that's going to automatically put zeros in all of your cells there. And so basically with this line, what we've done is we've just created this allocation in memory that looks something like this. It's called prime int. Its length is 9. It's all filled with zeros. The first cell is at index 0. The last cell is at index 8. And that's easy enough, right? Now, if we want to get our string array, right, these are all strings, we want to get them into numbers, there's a really easy way to do it, right? We can just loop through this array, again using a for loop, and then we can take this string value, convert it to a number, and store it inside of this new array. So what happens is we create a new variable called I. It's an integer. Its scope is the for loop, and its initial value is 0, right? We're going to check to see if that variable I is less than prime string.length, which we've already said is 9, right? Right, so 0 through 8 would be 9, so we have 9 indices to look at. The first thing we're going to do is we're going to take whatever value is stored at prime string I. Well, I right now is 0. Prime string I at index 0 would be the string 11. We're going to take string 11, we're going to parse it into an integer, and we're going to store that into prime int at index I. Well, prime int at index I is right here, right? We're still the 0th index. So essentially we're taking the string 11 and we're putting it, or we're converting it to a number 11, right? We're going to increment I is going to become 1. Oops, not all of that. I is going to become 1. We check to see if 1 is less than 9. It is, so that means it's true, so we're going to do this again. Now we're going to look at prime string at index 1, which is the string 13. We're going to convert that to a number, and we're going to store that in our new array called prime int at index 1, right? Because I is still 1, so this will become 13. Again, I'm not going to trace this all the way through, but you can see that what's going to happen here is we're going to get a new array, an integer array, that looks something like this, right? Once we finish our for loop, this goes away, gone. And what we're left with after this code executes is that we have this thing in memory called prime string. It's sorted alphabetically right now. It looks like this, and because we just did what we did, we declared a new integer prime int array, and then we looped through the string array, and we converted each string to an integer, and then we saved that new integer value inside of our prime int, which is an integer array at its corresponding index. All right, so the next thing we want to do is we want to sort this prime int array. And then if we sort the array, we should expect to see that it's now numerically sorted, right? So sorted prime array is the label. This time when we call our print array method, right, we're sending it prime int. Prime int is not a string array, it's an integer int. So we're not going to use this version of print array. We're going to use this version of a print array. Incidentally, the code is exactly the same, but because we want to be able to send it an integer array instead of a string array, we have to replicate this method, right? So we know what this method is going to do. It's just simply going to print all the values of the array out on the line. So we've got our integer array. We sort it right here, and this should do a numerical sort. And then we're going to print our array again. So let's run this and see what we get. So the original array that we created looked like this, and that's stemming from using the split function of this string right here. We then sorted the array while it was still a string array, and we get this weird sort of alphabetical sort. And then what we do is we take our time and we create an integer array, and then we basically parse each value and store it into the integer array. And then when we sort it, now you'll see that we get an actual numerical sort. Very simple examples, right? So let's do this. I've been talking about how things look weird when you print them if you just were to print days of the week, or print name, or prime string, or print prime int. So what I've done here is I've basically just included an example of what that might look like. So I'm going to leave everything else as is and just run this. And now you'll see that the memory address of prime int array, so prime int array is right there. The memory address is this value right here. So really, I put garbage up here, but we could put this value right here. And what this is telling Java is that this variable called prime int, it's an integer array, it's actually stored in memory at this memory address. This memory address essentially is pointing to something in memory that looks like this. Okay. So if you, in your travels or in your programming, if you try to just print an array in this fashion, right, where I'm just printing the variable prime int, I'm not looping through and looking at specific indices within the array, you're going to get some weird output that looks like this. So if you see that, now you know exactly what's going on. There are implications for this. We talked about in class. I'm not going to really harp on that here because it doesn't matter this week. But when we begin to talk about classes and creating our own objects, our own data types, this notion of a pointer being here rather than an actual value can become kind of important. So we'll get on that later on in the semester. The last thing I really wanted to do is I wanted to talk about multidimensional arrays. So as you can imagine, and all this stuff still exists, I'm going to go up here and comment out these print statements that I uncommented. I'm just going to comment all of this. Actually, I can leave all this stuff. Just know that this stuff is still out there, but for the sake of making it easy on myself, I'm going to pretend like it doesn't exist, okay? And we're starting fresh. Okay, So let's assume that all of this doesn't exist, and now we are really just focusing on what's going on down here. Okay. So the way that you would declare a multidimensional array looks exactly the same, and you can do a lot of the same things, right? You can declare a multidimensional array by using the data type. Instead of having a single set of square brackets, now you have two sets of square brackets. You still have a name, and then you can either provide a value list. So if you want to go ahead and populate your array, or you could do something like this, right? If just for example, where this would be, you could give it a length, say 5 by 10, right? Inside of multidimensional arrays, the first bracket represents the number of rows, and the value inside the second bracket represents the number of columns. So if you did something like this, you'd be saying, I want an array that has 5 rows and 10 columns. Also, when you're talking about values of arrays, if you said I wanted, give me the value my array at index 4 and index 3, you're talking about give me the value at row 4 at column 3. Okay, we'll see this a little bit in a second when we trace this this times table. Okay, so what I've done is I've declared a variable called times table. It's an integer multidimensional array. Its scope is still the main method, and its value is some weird memory location, right? Whatever that is. We don't really care. Now, what this is going to look like is basically a times table, so not that exciting. But what we have here is we have a curly brace and a curly brace, and then we have inside the curly brace for a multidimensional array, you'll have basically comma delimited sets of curly braces. In this case, we're dealing with integers. If we were doing with strings, we would have string values here. If we were doing with booleans, we'd have boolean values here, etc., and so on. And so what this is going to look like is something like this once we declare it in memory. It's going to say 0, 0, 0, 0. Let me just make these so we can see them. There we go. Right, 0. Oops, 0, 2, 3. This should be a 4. Let's fix that. Right. 0, 3, 6, 9, 12, and then 0, 4, 8, 12, 16. All right. So essentially what we have is a matrix that looks like this, or an array. A multidimensional array looks like this. And this would be index 0, 1, 2, 3, 4. This would be index 0, 1, 2, 3, 4, right? So we have a 5 by 5 array. This would be the rows, obviously. These would be columns. But conceptually in memory, we've just created something that looks like this. The variable times table has the value of a memory address saved in it that's pointing to this thing over here that exists in memory, right? Now, if we wanted to print this array called times table, we now have a times table, which we know is an integer multidimensional array. So we're going to call print array times table. We're sitting in a multidimensional array, so we know that it's not this one, right? That's a string array. This is an integer array, but it's a single dimensional array. This is an integer array that's a multidimensional array, which is what we're working with. And then we have the label that we're still passing it, right? Now, if we come in and we look at this, if you think about the easiest way to sort of iterate through each one of these values and print them out, what makes sense to do is to basically do a for loop inside of a for loop. So basically, we're going to loop through each column, and then as we loop through each row, right? And that's kind of what's going on here. So if we look at what happens, we have this thing in memory called A. I'm not going to draw it out again, but basically it's in A. It's called A. It's an integer array. Its scope is print array. It's got some memory location, which essentially is pointing to something that looks like this. Again, I'm just not going to copy it over. And the first thing we're going to do is going to print a label, which says 0-4 times table. And then we're going to create something in memory called I. See everything. All right, so we have, this is times table. We have I, it's an int. Its scope is the for loop, and its value is initialized at 0. And when we look at a.length, now here's the interesting thing. So if you want to know the number of rows, which is what we've been doing so far, we just have the name of the array dot length. That's going to give you this number of rows, right? In this case, it would be 5. If we want to know the number of columns, we would use something like this. It's very similar, but instead of saying a.length, we say a at a particular row. We want to know the length. And so usually it's good practice just to use the value 0 here. But we're going to start with this. We would say basically give me the length of this row is what we're kind of saying, which would also in this case be 5. So basically we're going to say I equals 0. We're going to check to see if I is less than a.length. Well, a.length is the number of rows, so that's going to be 5. So 0 is less than 5. So that's true. So that means we're going to come inside the body of our for loop. When we get inside the body of our for loop, we're going to create a new variable called j. Int as well. If I can make it. So type that. The body is a for loop, and it's initialized to the value 0. And we're going to check to see if 0 is less than the number of columns, right? This is the number of columns. This is the number of rows. So if j is less than the number of columns, which is 5, 0 is less than 5, that's true. We're going to print out the value at a at ij. So I is 0, j is 0. So we're saying we want to print a at row 0, right? Row 0 is right here. We want to print a at row 0 and a at column 0. 0, 0 would be this guy right here, right? We're going to print that with a space. The next thing we're going to do is we're going to increment j. J is going to become 1, right? J is going to become 1. We're going to check to see if j is less than the number of columns. So j is less than, or 1 is less than 5. That's true. So now we're going to print I, or a at ij. So I is still 0, so we're still at row 0, but now we're at column 1 because j is 1. So we would print 0 again. You can see that we're going to keep going through this process until j eventually will become the value of 4. And we'll say, is 4 less than 5? That's true. So we're going to come into the body of our j for loop. We're going to print a at index ij. Well, I is still 0, and j is 4. So now we're talking about row 0, column 4. We're going to print 0 again. Now when we get to the end of this execution, we're going to increment j. J is going to become 5. 5 is going to, we're going to see if 5 is less than 5. Is 5 less than the number of columns in the array? The answer is no. So it's going to be false. So we're going to drop out of our loop. We're going to print a carriage return. And then we're going to hit the end of our I loop. Now we're going to hit I, and we're going to increment I. Well, I is going to become 1. We're going to see is 1 less than the number of rows of the array. 1 is less than 5. That's true. So we're going to basically come back into our for loop. We're going to reinitialize j at 0. We're going to check to see if 0 is less than the number of columns, which is 5, which is true. 0 is less than 5. So now we're going to print a at ij. Well, I is 1. So we're looking at row 1, and j is 0. So we're looking at column 0. Now I won't keep chasing this out. You can kind of see what's going on. But essentially, every iteration of the loop is going to go through our array and basically print it out looking just like this. Right? Right on through. If I run this, what you would see was what you expect to see, right? We're going to print the label. So we print the label, which says 0-4 times table corresponds to this parameter label. The times table corresponds to this integer array A. And then, like I was just saying, we're going to basically loop through each row and each column, and we're going to print out the value of that particular index. After we do that, we reach the end of our main method, which means that our program is done executing. All right, so this is just a very brief, I don't know how brief it was. It's an overview of arrays, right? So this is kind of the meat and potatoes of arrays. You will use arrays all the time in real programming. You need it for the assignment, obviously, this week. Hopefully this resonates, makes sense. If it doesn't, feel free to shoot me a note and ask me questions, and we'll get you squared away. All right.